Welcome back to our Factors That Affect Dissolving lab. We're going to be doing part B in this video. So if you're looking for part A, you need to turn off this video and go to the previous one. With this part of the lab, we're going to look at dissolving a gas in a liquid. Specifically, we're going to look at carbon dioxide in water. Now, we don't have the equipment to actually look at dissolving a gas in water. That's a really hard thing to do. Gases don't want to be dissolved. They seem to take every opportunity possible to undissolve. So that's what we're actually going to do in this lab. We're going to look at undissolving the carbon dioxide gas from this bottle of soda water here. And from this, we will infer that if something makes this undissolve, we would not want to do that to dissolve it in the first place. We'd want to do the opposite. So at the end of this lab, you're going to have to think in opposites, but that's okay. The lab specifies that as you're going through the analysis questions. So I have soda water here, club soda, okay, and you need to make an observation. So like a one-sentence observation right there on your lab paper. There should be a line for it. And I want to show you right now that I'm trying to squeeze this and nothing is happening. Like, check that out. Like, even two-handed, I really can't. What's that tell me about the pressure in this bottle? Yes, it is high pressure in this bottle. With this high pressure, how well dissolved is this gas? Look at that. It sounds like a trick question. You're like, there's no gas in there. Well, I know there's gas in here because I bought it that way. All right, but yeah, make that observation. The pressure is really high and the gas is definitely well dissolved in there. So be sure you make that observation. Okay, now I'm going to open it. And hopefully from experience you know what's going to happen when I open the cap. I'm going to hear a psh. What is that psh sound that I'm going to hear? That is the pressure releasing. So right now I have high pressure. I can't squeeze this at all. When I open up the lid, I'm going to get low pressure. Now watch what happens to how well the gas is dissolved at low pressure. So I'm going to open the lid. I heard a psh, releasing the pressure. Whoa, look at that. Yeah, all those bubbles. And I can do it again and again. There's lots of bubbles in here. Lots of gas was dissolved. Now what do we notice? Okay. First off, I'll point this out. Now when I squeeze, I can actually bend the sides in. You should be able to see that on the video there. I'm actually squeezing the sides in. So the pressure is much, much lower than it used to be. And look at all those undissolved bubbles of gas. So make an observation, probably a single sentence is sufficient, about the pressure now and how well dissolved the gas is. So we're at low pressure. And this gas is, not well dissolved. Okay. So pause if you need to make those observations. What I'm going to do is, as the lab says, I'm now going to place 50 milliliters of the club soda into each of my cups. So I'm going to add, just measuring with my beaker here, 50 milliliters of club soda into cup A. I'm going to add 50 milliliters into cup B. And I'm going to add 50 milliliters into cup C. And I'm looking for the factors that affect how well this gas is going to undissolve. In other words, I'm looking to get rid of the bubbles because that's undissolved. So this cup A, is going to be my control. This cup B, I'm going to stir. And this cup C, I'm going to have floating in this large beaker of really hot water. Okay, so I'm going to stir. And how long do I need to stir? I need to stir until there's no more bubbles. How long do I let cup C float in the beaker of hot water? Until there's no more bubbles. So I'm stirring and it feels like the more I stir, the more bubbles there are, but that's okay. I really am undissolving the gas. I'm also at the same time watching cup C. You have a pretty good view of what's happening in cup C there. Cup A is our control. We're doing nothing to cup A, so it's our standard for comparison. I just have a few more bubbles to get rid of. Almost out of bubbles here in my stirred cup. I'm clearly seeing a lot of bubbles rising and popping in the heated cup. Let's see what I got. All right, that looks like it in my stirred cup. My stirred cup is completely free of bubbles, so clearly that's first place. Got rid of the bubbles first. So if stirring got rid of the bubbles first, what would I do with stirring if I want the bubbles to go in? That's what you need to be thinking about in the lab. Okay, so next up, I'm going to be comparing my control with the cup that's being heated. It's one of these two that's going to happen next. Okay. So I'm going to let this video run. At the end, we go for 10 minutes, and then we rank them in terms of which one lost the most bubbles. So I'm just going to let this run for like 10 minutes, and you can just keep watching. You can fast forward. I will wave when I decide 10 minutes is up. So Okay, if you've not been watching, welcome back. Hello again. All right, so we've been letting this run. It's now time for comparisons, because that's why I have a control there, so I can understand for comparison. So for a moment, I'm going to take that hot water one and put it to the side there. I'm going to hold up these. Get the stir stick out of the way, okay? So this was my control, and this is the one I stirred. And I thought originally I stirred it until the bubbles were gone. Clearly there's a few bubbles left, but definitely got rid of the bubbles in stirring. That's undissolving the gas. I would not want to stir to dissolve the gas. That would be bad. But stirring undissolves the gas, and so that's what we learned in lab. Okay, so now here is my control, and here's the cup from the hot water. And you can see, I hope you were watching on the video, it was like forming big bubbles and they were coming to the top and popping. Give you like a side view here. Okay, still lots of bubbles in my control, still sitting there, not flat yet. And here I have just a few left. So hot water definitely sped up the undissolving. So if hot water makes it undissolve, I would not want to heat it to dissolve it. I'd want to do the opposite. Yeah, I'd actually want to cool it down. Hopefully you have experience with this. A cold Coke from your refrigerator will stay fizzy longer than a hot Coke from the inside of your car parked in the Texas heat. So we looked at stirring helps undissolve it, so don't do that to dissolve it. Heat helps undissolve it, so don't do that to dissolve it. All right, and then there's our control still hanging out there. All right, so make your observations in your chart, rank them, which one left first, which one left second, and then the third is the third, obviously. And you have a bunch of analysis questions to answer. Keep in mind, what we did in this part of the lab, part B, is the reverse of what I'm going to ask you. I'm going to be asking you what would be good to help it dissolve. So I think the question says that very carefully. Be sure that you think of it correctly, though. Good luck.